September 17, 1944, 14,000 ft above Eindhoven in the Netherlands. The opening day of Operation Market Garden began with the largest airborne assault in history. Across the Dutch countryside, Allied paratroopers dropped in massive waves supported by thousands of aircraft. Among them were squadrons of P-47 Thunderbolts, circling high above the landing zones. These fighters carried bomb loads that would have been unthinkable just 18 months earlier. For German Luftwaffe pilots rushing to intercept, the sight was shocking. The Americans had turned their bulky Thunderbolt into something extraordinary. Each single-seat, single-engine fighter was hauling up to 2,500 lb of bombs, half the payload of a B-17 Flying Fortress, while still able to fight on equal terms with enemy aircraft. The fighter they had dismissed back in 1943 as slow and clumsy had now become a devastating hybrid. It could fight its way in, bomb like a light bomber, and then battle its way home. This transformation didn't just alter tactics. It sped up the collapse of the Wehrmacht and rewrote the rules of air warfare. When the Republic P-47 first entered combat in April 1943, it seemed to confirm every German stereotype about American design. It was big, heavy, and powerful, but supposedly lacked finesse. On April 8, 1943, the 4th Fighter Group flew the first official mission with the type. German intelligence analyzed its specifications and came to predictable conclusions. The Thunderbolt weighed 10,000 lb empty, double the Messerschmitt Bf-109G. Its giant Pratt & Whitney R2800 double Wasp engine, an 18-cylinder radial generating 2,000 horsepower, later versions reaching 2,300 and eventually quick 800 horsepower, was forced to push a design that looked anything but streamlined. Early combat encounters seemed to prove German assumptions correct. With an initial combat radius of only 125 mi, the P-47 could barely serve as a bomber escort. Its climb rate was inferior to German fighters, and in medium-altitude turning battles, both the Focke-Wulf 190 and the Bf-109 easily outmaneuvered it. German pilots developed tactics to exploit this, forcing Thunderbolts into turning fights or vertical maneuvers where weight worked against them. What German analysts failed to see was that they were looking at an aircraft designed for much more. Its heavy steel frame and armor, which made it seem clumsy, also gave it unmatched toughness and the ability to carry huge external loads. The wing pylons, first meant for long-range drop tanks, were actually built strong enough to carry up to $2,500 LEB of bombs, more than most fighters of the time could dream of lifting. The transformation of the P-47 didn't start with strategy papers, but with practical field use. In 1943, pilots escorting bombers began attacking targets of opportunity on the way home: locomotives, convoys, and fuel depots. Results were immediate and brutal. With 8 Browning M2, 50 caliber machine guns, each firing 800 rounds per minute, the Thunderbolt poured 12.7 LLB of lead every second, enough to rip open a locomotive or shred trucks to pieces. The first official bomb-carrying version appeared in November 1943. Bomb shackles rated for $500 LB were fitted under the belly and wings. On November 25, 1943, the 62nd Fighter Squadron carried out the first true P-47 bombing mission, striking the Luftwaffe airfield at Saint-Omer, France. 8 Thunderbolts, each loaded with 2 250 lb bombs, destroyed 2 hangars and damaged 5 aircraft. Through the winter of 1943 to 44, Republic engineers and the U.S. Army Air Forces pushed the design further. Wing spars were reinforced so the plane could handle uneven loads when one bomb dropped before the other. New electrical bomb release systems worked at both high-altitude and low-level flight. The K-14 computing gun sight was added, allowing precision in dive and glide bombing. By 1944, the P-47 was no longer just a fighter with bomb racks. It had become a dedicated fighter bomber. It could even carry M84.5 rockets, each with the impact of a 105 mm artillery shell. A single Thunderbolt now carried 10 rockets and 2 1,000 lb bombs, packing more explosive force than many twin-engine bombers at the start of the war. D-Day, June 6, 1944, proved what the P-47 had become. On that single day, Thunderbolts flew 1,185 sorties, dropped 525 tons of bombs, and fired 135,000 rounds of 50 caliber ammunition. They destroyed 86 locomotives, 507 vehicles, 38 gun positions, and 17 fuel dumps. The aircraft once mocked as a poor interceptor was now the backbone of tactical air power in Europe. Even top German aces could not ignore it. Luftwaffe pilot Günther Rall, who scored 275 victories, recalled in a 1996 HistoryNet interview that the Thunderbolt shot him down in 1944. He admitted the P-47 had incredible diving speed up to 400 km/h compared to the Bf-109's 1,000 km/h. On May 12, 1944, Rall was downed by P-47s of the 56th Fighter Group, losing his left thumb in the fight. His torn glove from that mission is now displayed at the National Air and Space Museum. After the war, Rall flew captured P-47s for about 300 hours while evaluating Allied aircraft. The Thunderbolt's ability to switch instantly from bomber to fighter created an unsolvable problem for the Luftwaffe. German pilots sent to attack what they thought were slow, bomb-laden targets suddenly faced fully armed fighters that had just dropped their payloads. With raw firepower, rugged durability, and unmatched versatility, the P-47 proved to be far more than the Luftwaffe ever expected. The numbers behind the P-47's payload made German supply officers face an impossible problem. A standard P-47 D-25 could carry multiple loadouts, 2 1,000 lb bombs, 3 500 lb bombs, or a mix of bombs and rockets adding up to $2,500 lb. That equaled 5% of a B-17's regular $4,000 lb bomb load on long-range missions. In short, almost half the striking power of a flying fortress on a single-engine fighter. A squadron of 16 Thunderbolts could deliver 32,000 lb of bombs, equal to the output of 8 B-17s flying with standard loads. The difference was in frequency. Heavy bombers leaving England managed 2 missions per week, while P-47s from forward bases could fly 3 missions a day. That meant one fighter squadron could drop more tonnage in a single day than a heavy bomber squadron could manage in an entire week. The manpower gap was just as sharp. One P-47 with 2 500 lb bombs required a single pilot and a small ground crew. A single B-17 loaded with 4,000 lb needed 10 aircrew, plus a large specialized support team. The fighter bomber's destructive return on manpower was unmatched. The most devastating proof came in August 1944 during the Falaise Pocket. Between August 12th and 21st, German forces trying to break free of encirclement were hammered from dawn to dusk by rotating groups of Thunderbolts. Each squadron flew in shifts with fresh units arriving as others refueled and rearmed, creating non-stop pressure. Ground-checked kill claims reveal the impact. On August 13th, 112 tanks destroyed. August 14th, 287 motor vehicles destroyed. August 15th, 42 locomotives destroyed. August 16th, 89 horse-drawn vehicles destroyed. By the end, analysis showed about 1/3 of all German vehicles in the pocket were lost to air attack, with P-47s doing most of the damage. In September 1944, the U.S. introduced the 5 in High-Velocity Aircraft Rocket, or HVAR. With a 60 lb warhead, it could pierce the armor of even the Tiger and Panther tanks. A single P-47 could carry 10 of these rockets, releasing the equivalent firepower of an artillery battalion in one pass. The 362nd Fighter Group pioneered the tactics, diving from 5,000 ft at a 30-degree angle, firing at 1,500 ft and landing direct hits on 30 to 40% of their shots, accuracy far beyond artillery rates. By December 1944, the Thunderbolt had proven itself as a true all-weather fighter bomber during the Battle of the Bulge. Fog, ice and snow grounded much of the Allied air fleet, but P-47s fitted with British rocket rails and upgraded instruments continued to operate. When skies cleared on December 23rd, Thunderbolts flew 647 sorties, destroying over 400 vehicles in a single day. Between December 23rd and 27th, the statistics spoke for themselves. 201 tanks destroyed, 930 motor vehicles destroyed, 53 horse-drawn vehicles destroyed, 89 locomotives destroyed, 512 railcars destroyed, and 47 bridges destroyed or damaged. January 1945 highlighted another capability: precision bridge strikes. The 56th Fighter Group perfected techniques using 1,000 lb bombs. 8 P-47s diving at 60 degrees could hit within 500 ft of target, double the accuracy of heavy bombers, which often missed by 1,000 ft or more. Bridges that had survived repeated B-17 attacks were finally dropped by Thunderbolts. The German Me-262 jet entered combat in early 1945 with a 100 mph chase speed advantage over the P-47, seemingly untouchable in the air. But the Thunderbolt's role as a fighter-bomber exposed a new weakness. The Me-262s needed long concrete runways and burned through fuel quickly, making their bases prime targets. On March 21, 1945, P-47s of the 365th Fighter Group caught JG-7's jets during takeoff at Leipheim Airfield. Trapped on the runway, the Me-262s were unable to maneuver or accelerate to safety. In just 5 minutes, 8 jets were destroyed, more than German industry could replace in a week. The next month, Operation Clarion in March 1945, brought the complete destruction of Germany's transport network. P-47s were assigned wide sectors with orders to destroy anything that moved or supported movement. On March 22 alone, Thunderbolts claimed 89 locomotives destroyed, 1,026 railcars destroyed, 155 vehicles destroyed, 17 bridges dropped, and 93 rail cuts. The German transport system never recovered. The P-47D-25, introduced in mid-1944, was the centerpiece of this transformation. It featured stronger wings rated for 3,000 lb of external stores, universal shackles for both American and British ordnance, zero-length rocket launchers to reduce drag, upgraded cooling systems for extended low-altitude flight, paddle blade propellers for faster climb, water injection raising engine output to 2,800 horsepower, and the K-14 computing gun sight for accurate dive bombing. Republic Aviation's Farmingdale and Evansville plants kept the production lines running without pause for 48 months. At peak, 35 Thunderbolts rolled out each day. Across the program, 28 major variants were produced and 430 modification kits were developed. This level of non-stop adaptability was unmatched by any other fighter manufacturer during the war. Pilots had to be reshaped from pure fighter specialists into all-role combat aviators. The U.S. Army Air Forces created training programs requiring at least 200 flight hours before combat. This included 50 practice bomb runs, 20 rocket firing passes, 100 strafing runs, 40 hours of instrument training, and 30 hours of formation practice. By contrast, late-war Luftwaffe training had dropped to only 110 hours, with no fighter bomber training at all. By 1945, Thunderbolt pilots could handle every mission type: high-altitude escort, medium-altitude combat, low-level navigation, dive bombing, skip bombing, glide bombing, rocket attacks, napalm delivery, and strafing runs. They shifted roles as missions demanded, turning the P-47 into the most versatile combat aircraft of the European theater. February 1945 introduced a new weapon for the P-47, napalm bombs. Standard 150-gallon drop tanks were filled with jellied gasoline, creating fire weapons capable of wiping out entire city blocks or fortified forest positions. The 362nd Fighter Group carried out the first combat use on February 14, 1945. Their target was a Wehrmacht supply depot hidden in the Reichswald forest. 8 Thunderbolts, each loaded with 1 napalm tank and 1 500 lb bomb, created a massive firestorm. Flames were visible from 20 miles away, and within minutes 3 acres of supplies were completely destroyed. From March through May 1945, the Thunderbolt reached the peak of its wartime evolution. The P-47M entered service with a top speed of 470 mph, matching the performance of early jets. At the same time, the P-47N was built for Pacific operations, demonstrating a range of 350 miles with bombs. But what made the P-47 truly revolutionary was not just speed or range. It was its ability to carry out almost any mission. Thunderbolts worked as forward air controllers guiding other aircraft, acted as artillery spotters for ground forces, flew photo reconnaissance missions, operated as airborne communication relays, dropped propaganda leaflets for psychological warfare, and even delivered emergency supplies to trapped units. A single aircraft type could perform 6 completely different missions in one day. The statistics tell the scale of the achievement. A total of 15,683 P-47s were built. It became the most produced American fighter of the war. Republic's Farmingdale plant produced 9,086 aircraft, Evansville produced 6,242, and Curtiss Wright in Buffalo built 354. Peak output reached 35 aircraft in a single day. The unit cost fell from 115,594s in 1942 to 83,194s in 1945, even as performance and capability increased. Combat operations show the true impact. More than 746,000 sorties were flown. Combat losses totaled 3,499 aircraft, while non-combat accidents claimed 1,623. The overall loss rate per sortie was only 0.7%. In aerial combat, the Thunderbolt achieved a kill ratio of 4.6 to 1. The ordnance delivered was staggering: 132,000 tons of bombs, 35,000 rockets, and 119 million rounds of 50 caliber ammunition. Confirmed destruction in the European theater included 3,916 enemy aircraft in air combat, 3.22 destroyed on the ground, 9,000 locomotives, 86,000 railway cars, 68,000 motor vehicles, 6,000 armored vehicles, and 60,000 horse-drawn vehicles. The P-47's success reshaped strategy itself. Before the war, air doctrine separated roles: heavy bombers for strategic targets, fighters for air superiority, and attack aircraft for close support. The Thunderbolt erased those boundaries. Its destruction of Germany's transportation network accomplished in months what years of heavy bomber raids had failed to achieve. By April 1945, German supply lines had collapsed. Movement in daylight became impossible. Reinforcements never reached the front, and logistics ground to a halt. The Strategic Bombing Survey confirmed the effect. By March 1945, fighter-bomber operations, driven largely by P-47s, had cut German rail traffic in forward areas by 75%. This transportation paralysis had more impact on Germany's defeat than the strategic destruction of industrial plants. The lesson was clear: mission flexibility created more combat power. A fighter that could only dogfight was half as valuable as one that could fight, bomb, and destroy infrastructure. This forced a complete shift in U.S. doctrine. The first Air Force manual in 1947 declared, "The artificial distinction between fighter and attack aircraft has been rendered obsolete. All fighters must be capable of ground attack. All attack aircraft must be capable of self-defense." This directly overturned the 1935 Army Air Corps manual, which had insisted that pursuit aviation's only purpose was aerial combat. The P-47 had proven that versatility was the future. The influence reached far beyond World War II. When the Korean War erupted in 1950, the direct descendants of the Thunderbolt, the jet-powered F-84 Thunderjet and the F-86 Sabre, entered combat configured as fighter bombers. The multi-role fighter model pioneered by the P-47 became standard doctrine worldwide. Republic Aviation's achievement was also a triumph of American industry. Founder Alexander Kartveli designed the P-47 with massive safety margins. The Army Air Forces asked for a structure stressed to 6 Gs. Kartveli built it for 12. They requested 500 lb bomb capacity. He gave them 2,500. This overbuilt design allowed the aircraft to absorb upgrades, modifications, and new weapons without pausing production. Every Thunderbolt leaving the factory in 1945 included hundreds of improvements based on frontline experience. Yet production never halted for redesign. For 48 straight months, output continued. 15,683 aircraft, 28 major variants, 430 field modification kits, and a daily peak of 35 fighters produced across 2 plants. Cost dropped by 27% while capability rose. The concept behind the P-47 shaped every fighter built after the war. Its direct successors, the F-84 Thunderjet and the A-10 Thunderbolt II, carried its name and its ground attack legacy forward. The P-47 proved once and for all that the future of air combat lay in versatile multi-role fighters. The Republic P-47 Thunderbolt set the foundation for every fighter bomber that came after it. The F-105 Thunderchief carried this philosophy forward as a strategic fighter bomber. The F-4 Phantom II was built as a true multi-role aircraft, with control and adaptability at the center of its design. The F-16 Fighting Falcon, initially created as a lightweight fighter, grew into one of the most capable fighter bombers in history. The F-15E Strike Eagle, built as an air superiority fighter, proved it could also perform devastating strike missions. From the start, the F-A-18 Hornet was designed as a dual-role fighter attack aircraft. The F-35 Lightning II represents the peak of this evolution, an ultimate multi-role fighter replacing many older specialized aircraft. This entire lineage can be traced back to the P-47's revolutionary concept: build strong, build adaptable, and let real combat needs shape the future. The P-47 program didn't just change aircraft design, it also transformed pilot training. The training program developed for Thunderbolt pilots became the global standard. Pilots were no longer trained for just one mission type. Instead, they learned air-to-air combat, air-to-ground attack, reconnaissance, and even electronic warfare. This multi-role approach, pioneered by P-47 squadrons, set the standard still followed today. The requirement for 200 hours of pre-combat training for P-47 pilots became the baseline for air forces worldwide. Special emphasis was placed on instrument flying, formation tactics, and precise weapons delivery, skills that shaped professional aviation for generations. Even Luftwaffe veterans admitted after the war that the P-47 was decisive. General Adolf Galland, who flew captured Thunderbolts after 1945, gave his testimony in a 1996 HistoryNet interview. He praised the aircraft's comfort, durability, and versatility, and highlighted one surprising detail. The P-47's engine didn't leak oil, something German fighters constantly struggled with. The statistics back up these accounts. By the war's end, the Luftwaffe could only put about 100 fighters into the air on any given day. Not because aircraft weren't available, but because P-47s had destroyed their fuel depots, airfields, and supply chains. The Thunderbolt achieved what years of strategic bombing could not: total paralysis of German operations. The P-47 also delivered unmatched efficiency compared to heavy bombers. The cost per ton of bombs dropped was $28,000 for the B-17 Flying Fortress, $24,000 for the B-24 Liberator, but only $4,200 for the P-47. Crew losses told a similar story. For every 100 tons of bombs delivered, the B-17 lost 8. 5 crew members, the B-24 lost 7. 2, while the P-47 lost just 0. 9 pilots. Support requirements were also drastically different. The B-17 needed 47 ground crew per ton of bombs delivered, while the P-47 needed only 8. In short, Thunderbolts delivered destruction at 15% of the cost and with only 10% of the manpower compared to heavy bombers. The transformation of the P-47 from a pure interceptor into a fighter bomber that could carry half the bomb load of a B-17 was more than a technical upgrade. It was proof of America's ability to adapt with unmatched pragmatism. The Luftwaffe never expected this because their doctrine emphasized narrow specialization: the best fighter, the best bomber, the best attack plane. The U.S. approach, built on industrial strength and practicality, valued adaptability and efficiency above all. The P-47 showed that in modern war, flexibility beats specialization. This reality hit the Luftwaffe hard. On September 17, 1944, when German pilots faced P-47s over Eindhoven, they weren't just up against another fighter. They were facing a revolution in warfare. The clumsy Thunderbolts they dismissed in 1943 had turned into the very aircraft dismantling their war machine, not by excelling at one role, but by mastering many. The Thunderbolt's combat record from 1943 to 1945 speaks for itself. Maximum speed, 433 mph for the P-47D, 470 mph for the P-47M combat radius, 450 miles with drop tanks, service ceiling, $43,000 FT, maximum bomb load 2,500 pounds. Total production, 15,683 aircraft. Monthly peak, 150 aircraft. Production cost cut by 27% across the run. Variants produced 28 field modification kits over 430 combat effectiveness. Total sorties, 746,000. Loss rate just 0.7% per sortie. Kill ratio, 4.6 to 1 bombs. Dropped 132,000 tons. Ground targets destroyed over $224,000. The lesson was clear. The Luftwaffe never imagined a fighter could carry half the bomb load of a B-17, and that failure of imagination cost them everything: air superiority, mobility, and ultimately the war. The P-47 Thunderbolt's shift from interceptor to fighter bomber remains one of the clearest examples of how tactical adaptation can bring about a strategic revolution. The German belief in narrow specialization doomed them. The American belief in adaptability won. Every modern fighter flying today, from the F-16 to the F-35, carries the DNA of the P-47. The heavy fighter that German pilots once dismissed as too slow and too big became the machine that crushed their war effort. Not because it was perfect in one category, but because it was strong enough, versatile enough, and adaptable enough to win across every mission. The P-47 proved once and for all that in modern warfare, the side that adapts fastest wins.